Hello and welcome to lesson 1F. I can find the midpoint and length of a segment. All right, so we're going to start today by talking about midpoints. And a midpoint is the point that's exactly halfway along a segment. So we say that point C is a midpoint of AB if and only if AC is congruent to CB and C is between A and B. Informally, it's the exact center of a segment. So let's take a look right here. If I have point A at coordinate 2, so let's call this guy right here point A, and point B at coordinate 8, that's B, and I want to find the midpoint. It's the point that's exactly halfway between them. Now, if we were younger, we'd probably count and go, well, there's 1, 2, 3, 4, 5, 6 units between them. So halfway would be 3 units along. 1, 2, 3, that would be 5. But there's a more sophisticated way. The midpoint is really just the average. So if I were to do 2 plus 8 divided by 2, that's 10 over 2, which is 5. So my midpoint is really at the average of my coordinates. So if I want to find, so let's take a look at -5 and 7 now. Well, -5 is way down here, and 7's way up here. Well, my distance between them, right? Remember last time we learned that distance is really the absolute value of the difference. Absolute value of -5 minus 7 is going to get me a distance of 12. And the midpoint's halfway between them. So I would add -5 plus 7 divided by 2 gets me 2 over 2, or 1. So my midpoint here is actually at 1. And if we look, -5 to 1 is 6 units, and 1 to 7 is also 6 units, so it's exactly halfway. So you really just find your midpoint by taking the average of your coordinates. Well, the same actually is going to hold true when we look at coordinates in the coordinate plane with x and y axis. So now I've got the point 5, 3, so I'm going to plot it. 5, 3, which is right here, and the point -3, -3. -3, -3 is right here. Let's connect those. Well, if I'm going to find the midpoint of these, I'm actually going to consider the x's and the y's separately. So when I have the point 5, 3, that means I've got an x coordinate of 5 and a y coordinate of 3, right? And then I've got the point -3, -3, meaning I've got an x coordinate at -3 and a y coordinate at 3. Okay. Well, if I'm looking for the midpoint of the x's between -3 and 5, my midpoint here is -3 plus 5 divided by 2, or 2 over 2, which is equal to 1. So I have a midpoint here of 1. So I think my x coordinate is going to be 1. Now let's look at the y's. I've got a -3 and a 3. Well, -3 plus 3 over 2 is 0 over 2, so I expect exactly halfway to be 0. Okay? So that means I expect my y value to be 0. So looking at this, if I go to the point 1, 0, oh look, that's on that segment, okay? That's exactly halfway. Do you see how these two distances here are the same? Those guys end up being equal. So in order to find the midpoint, we really just take the average of the x's and the average of the y values. So if I want a midpoint, I'm going to call it xm comma ym. Okay, that's x value of the midpoint and y value of the midpoint. That's really equal to the average of my x values, x1 plus x2 over 2, comma, and the average of my y values, y1 plus y2 over 2. And that's all we do to find the midpoint. So guys, I want you to put a big star next to this in your notes. This is a big idea. Hang on to it. You need to know this for the rest of geometry. Copy it somewhere, put it on the front of your book, put it somewhere where you're not going to forget it, because you're going to use this over and over and over again this year. So, all right, let's practice it now. Now I want to find the midpoint between the 2 points, 2, -1, so 2, -1, which is here, and -4, 5, which is right here. So midpoint of this segment right here I'm going to do the average of my x values. So 2 plus -4 over 2, comma, and the average of my y values. -1 plus 5 over 2, which gets me, well, 2 plus -4 is -2, divided by 2 is -1, and then -1 plus 5 is 4, divided by 2 is 2. So my midpoint is at -1, 2, which if I could have drawn a straight line would have been right there, which would break that into 2 equal pieces. So you don't have to graph it to do this. Here I've got 2 points, -5, 3, and 4, 2. I want you guys now to apply this formula and try this guy now on your own. So go ahead and give it a shot, and we'll check our work here in a second. All right, so you don't get a pretty answer for this one, but that's okay. You get -1/2, comma 1/2. All right, let's take a look now at a slightly different kind of problem. What if we give you the midpoint, right? So I give you that xm comma ym is already equal to -2 comma 3, and I give you 1 point, that's my x1 comma y1, that's 9, 5, but I'm missing the other endpoint. That means I'm missing x2 comma y2, okay? Well, this is where I'm going to treat them separately, my x's separately, my y's separately, because I know that the x value of my midpoint is equal to x1 plus x2 over 2. And let's plug in. Well, the x value of the midpoint was -2, okay? And my x1 was 9, but I'm still hunting for that second x value, and we're dividing by 2. So to solve this, I would multiply both sides by 2 first to cancel this guy. So 2 times -2 is -4 equals 9 plus x2. Subtract the 9 to get -13 is x2. Now let's work on the y's. It's the exact same concept. The y value of the midpoint is equal to y1 plus y2 over 2. Plug in what you do know. You know that the y value of the midpoint is 3, and you know that y1 is 5, but you don't know y2. That's what you're hunting for, over 2. So this is where you start. Multiply by 2 on both sides. So you get 6 equals 5 plus y2, or 1 equals y2. So your missing endpoint ends up being -13, comma 1, and that's your answer. All right, guys, so to summarize, the midpoint can be found using the midpoint formula, which is the average of the x's and the average of the y's, and the midpoint lies exactly halfway between the segments. So again, this is a big idea, okay? Don't forget this. It doesn't go away. All right, let's keep going. Our second big concept today is going to be distance. And the distance between points A and B, which we discussed last time, if it's just on a number line, is the absolute value of their difference. And we sometimes denote difference with a triangle called delta. That's the Greek letter delta, which is to signify change in a variable. So you guys learned about delta when you learned about slope and you did change in y over change in x. So you've seen it before, but it might have been a while. But let's take a look at some more points again. Let's look at 5, 3. So point 5, 3, which is right here, and -3, -3. All right. So if we were to connect these 2 points with a nice straight line this time, you can actually make any line you draw between 2 segments into a right triangle by extending straight down and straight to the side until they meet to make this lovely right triangle right here. And when I look at this right triangle, I can see that the height of this right triangle, this length along this vertical edge here, goes between 3 and -3 for a length of 6, right? So that's a length of 6, which we really found by doing the absolute value of 3 minus -3, right? Equals 6. And then my horizontal length around here goes between -3 and 5. So is the absolute value of the difference of -3 minus 5, which really is 8. So whenever we have a right triangle, we can solve for the hypotenuse using Pythagorean theorem, using my a squared plus b squared equals c squared. And we just found that a and b is 6 and 8. And I'm hunting for that c squared. Well, that's 36 plus 64 equals c squared, or 100 equals c squared. Take the square root. So I get that 10 is in fact the length of c. So I can find the length of this segment using the Pythagorean theorem. So you can actually do that on these guys down here too. Let's do one more together, and then I'll let you guys do one on your own. So here, if I've got the point 2, -1, right there, and the point -4, 5, going straight up to right here, I'm going to connect my two dots, and then I'm going to look at the right triangle that forms when I pull them all together, okay? So the length of my vertical side here goes between 5 and -1, so he ends up being a length of 6. And then my base here goes between -4 and 2, so he also ends up being a length of 6. So if I want to find this distance, I'm going to call him x. I would do 6 squared plus 6 squared equals x squared, or 36 plus 36 equals x squared, which is 72 equals x squared. And now I need to take the radical of both sides. Well, again, this is big mastery test stuff, guys. 72 is 36 times 2, and 36 is 6 times 6, which is both 2 times 3. So if I look at the square root of 72, it's with the square root of 2 times 2 times 2 times 3 times 3. So a pair of 2's can break out, and a pair of 3's can break out. But we had one lonely guy in there, just the 2. So my answer is 6 square root 2. So the length of that side is 6 square root 2. All right, guys, I want y'all now to do this next one on your own and enter your answer into Edpuzzle. All right, so you should have gotten 9 square root 2 for your answer. Go ahead and check your work. Let's move on to the next problem. We can actually generalize all of this into an equation. If I look at the points x1, y1, and x2, y2, okay? So if I just have random points, I'm just going to label them x1, comma, y1, and then this random point over here, x2, comma, y2, and I, as I've been doing, connect them together with a straight line and make it into a right triangle, okay? I can find out that the length of my vertical side here, it's the difference in my y values. It's really the absolute value of y1 minus y2. And then this length here would be the absolute value of the x's, the absolute value of x1 minus x2, 2. Which means that this c squared over here, or I'm going to call this my distance, okay, would be x1 minus x2 squared plus y1 minus y2 squared is equal to my distance squared. Well, if I solve for this for just distance, I take the square root of the whole thing. And then you guys know whenever you square something, the result's automatically positive. So I really don't need the absolute value signs anymore. This derives the distance formula. And the distance formula is that the difference of your x's, x1 minus x2 squared, plus the difference of your y's, y1 minus y2 squared, and I take the square root of that, will actually get me the distance of anything. And we've actually got that written down here, written in delta notation, okay? This guy is your other big idea for the day. So I want you guys, again, just like you did with the midpoint formula, write him down, put him somewhere awesome. He's a big idea that's going nowhere and is all over the SAT, ACT, geometry exam, you name it. He's a big guy. So remember him. All right, let's put this into practice now. We're going to find the distance between the points using just the distance formula, okay? So I'm going to label this guy, just like we were doing when we were doing slopes in Algebra 1. We're going to call him x1, y1, x2, y2. We're going to plug him into our distance, where distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. So let's plug in. Distance equals the square root of x1 was negative 12 minus x2 is 12. Please write, pin. 12 squared plus the difference of my y's, 15 minus 22 squared, and we're going to simplify that. Distance equals the square root of negative 12 minus 12 is negative 24 squared plus 15 minus 22 is negative 7 squared. We're going to continue working this out. So we get 24 squared, which is 576, plus negative 7 squared, which is 49. And those two added together gets me the square root of 625. Well, I don't know if y'all know this, but the square root of 625 is in fact 25. So my distance between those 2 points is a simple 25 units. Let's do, I want you guys now to go ahead and do these next 2 examples on your own. And I'm going to throw up the solutions here in a second after you answer these questions on Edpuzzle. So go ahead and take a look at them. All right, guys, go ahead and check your work. You should have gotten 2 root 13 for the first one and 4 root 5 for the second one. All right, guys, and this last part is really more of an extension. I don't expect you to be able to know this, but if you're working on honors credit, this might show up in your honors section. This can actually be extended into 3-dimensional space where you're looking at your 3-axis coordinate system. We have x-axis, y-axis, z-axis. So if I have points in 3 dimensions, x1, y1, z1, x2, y2, z2, the formula works out the same way, where you end up with distance would equal the square root of the difference of your x's, x1 minus x2 squared, plus the difference of your y's, y1 minus y2 squared, plus the difference of your z's, z1 minus z2 squared. And so if you want to figure out the distance, you just plug into this formula. So I want you guys now to go ahead and try this. I'm not going to give you the answer here, but I think we're going to go over it in class together. So, all right, guys, that's the end of this lesson. Be sure to try this question down here and show it to your teacher in class. Thank you.